Welcome to this video on the loci of link mechanisms. So in this video we are going to be looking at this three-link mechanism. So in this mechanism we have the first link as OA, the second one is BD, the other one is BC. The lengths of these linkages have been given here. I'll be referring to them as I'll be going through the process of constructing the loci of point D in the link mechanism. So at the end of this video I'll add an animation that shows how this link mechanism works. But basically, if link OA rotates in the clockwise direction, it will push the linkages such that link CB will be oscillating, or it will be going back and forth about center C. So basically that's how the link mechanism works, but there will be a video at the end of the presentation so that you appreciate how this link mechanism works. So the first thing you do is you locate the centers of the link mechanism. So with these centers, it means that center O will be here and this will be center C. The next thing you need to do is to trace or to put a path of A and B in the mechanism. So if this is our center O and this is our center C, as link OA is going round in the clockwise direction, it will be going round this circle here. And if link CB is oscillating about C, this will be the path of position B. So the first thing you need to do is you divide the circle or the path of position A into equal sectors. So for this solution, we are going to divide the circle into 12 equal sectors. So with these divisions, we can now mark the position of A. So if we start from this position as A0, the position A will go around this circle all the way until it comes back to this position, which is position 12, meaning our position A has gone around the circle one revolution. So once we do that, we need to start locating the position of the linkages. So our first position, if the position of A is 0 here, and we know that from A to B it's 50 millimeters, what you need to do is you get your compass, you stand at position A, open your compass to 50 millimeters, strike an arc along this arc of oscillation where B will be oscillating. With your 50 at O0, you strike an arc along this arc here. So it means that you've located position B0, or the first position of B in the link mechanism. We also know that from B to D is 80 millimeters. So you stand at position B0, you open your compass to 80 millimeters, strike an arc here so that you locate the position of D0. So that's your first position of the linkage. So the first and last position of the linkage, you need to outline it so that someone will know how the linkage looks like when it starts and when it ends the movement of one revolution. So to locate the second position, we know that if position A moves from A0 to A1, the position of B will also move. So we know that the position of AB will always be 50. So you stand at position A here, open your compass to 50 millimeters, strike an arc on the arc of oscillation so that you locate position B1. With your B1 there, you stand at B1, open your compass to 80 millimeters. Since BD is 80 millimeters, strike an arc so that you locate position D1. So this here will be the location, the second location of our link mechanism. Our third position, we go to position A2. Standard position A2, strike an arc on the arc of oscillation 50 millimeters so that you locate position B2. To locate position D2, you stand at B2 here, strike an arc 80 millimeters along this line so that you locate position D2. So we go to the fourth position. We know that as the position A is moving around this arc, the fourth position will be at A3 here. So at A3, open your compass to 50 millimeters, stand at A3, strike an arc onto the arc of oscillation so that you locate B3. With your B3 there, open to 80 millimeters so that you locate position D3. So you continue doing this all the way until you come back to the first position here, which will also be the second position. So once you locate all the 12 position of the linkages, you are going to have the position of D as they've been highlighted here with the pink circles. So if you notice here, the only outlined position of the link mechanism is the first, which is also the last position. So that's all you need to outline to show how the link mechanism looks like. The remaining position should be in construction. So our main area of interest, or the loci we need, or the path we need, is the path of position D. So we've located the first position here, the second position, we have the third position, fourth position, all the way up to position 12 here, which is also the first position. So to trace the path or the loci of position D, you need to connect the position of D you've located using a freehand curve. So once you do that, you're going to have this path here as the path of position D, or the loci of position D in the mechanism. So this is the solution to our problem. Then we have an animation here that shows how the linkage moves. So as this linkage is moving, you notice that even if this link OA, or the yellow linkage here, even if it's moving at constant speed, you notice that the other positions in the linkages will be moving at different speeds. So that's one thing you need to appreciate about link mechanisms. Just because one position of the link moves at constant speed doesn't mean the other positions will be moving at constant speeds. They will be varying depending on how the linkage is. So that's how this link mechanism will be moving. So this is the end of the presentation. You can let me know in the comments the other topics that you might have challenges with, so that we can deal with them and you can be revising them whenever you need to revise.